What the heck? I hate this. Oh, I changed this file. I had 2 friends. And I go for a walk, I come back and it's like preset to something before certain edits. Yeah, no way. This is old code. Huh? Okay, here they are. These 2 must both be friends. So one is called handle extreme jump and the other one is called handle single sample step. Oh, and here I have 2 friends. What the hell? At least the code didn't vanish, but... Oh, I think I get it. Yeah. I get it, I get it, I get it. Hmm. Hmm. Okay, doesn't exist. I'll just add a new one called extra simple. Get extra simple. That is so not what I wanted. I wanted something that was safe. Now anyone can just call get extra sample. If you want to assign to W without side effects, just call extra sample. Even when you don't want to have an extra sample. Yeah, or just set the state. That will teach them to call this. And if then you still call it and then you set the state back to what you want because you didn't want it to get to be set to extra sample, yeah, then you're on your own. Mm-hmm. Hmm. No, I don't need a bit here. Yeah. I'll be right back. I have to defrost my chicken. Or I can never eat. Okay. Okay. There are so many different types of jumps, basically. Jumping to the extreme of a cubic. Jumping to the extreme of a cubic and then doing a step. Jumping to a node and then doing a step. Just doing a step. Jumping to the local extreme of a fourth degree approximation. Thought there were only a few different things, but turns out to be a lot. Thus forcing me to write a lot of different new functions. Then I have to think about if this is really different. Well, it must be different. The reason I want to make this distinction and get some function called, possibly calling that same function from multiple places, is because then I have to do something and I just want to implement that once or not forget to do it. So whether or not I need a new function stands or falls with what I need to do in that case? And to be honest, I don't know yet. So that makes it a bit hard. So I could just make a lot of different functions, but not a lot. Hopefully a handful at most, 5 say at most. But yeah, like jumping to the local extreme of a fourth degree approximation, I'm going to handle that. Going to use a different function than when I jump to the local extreme of a third degree approximation. Even though maybe, doesn't require anything different. And then if later I fill in what needs to be done in those functions and that turns out to be the same, then I can collapse multiple functions into one. I think that's the best approach. So that means I need a special function here for jumping to the local extreme of this fourth degree approximation. And so for those functions, then set these two values, which means I need a handle. Just a fourth degree approximation jump, no step. What we need is the fourth degree approximation itself. Yeah, as well as the, I guess, just the route where I want to jump to. It should all result in the same assembly anyway, because I'm going to inline these things. So I need to write this one now. Hello, deadly programmer. No. Double. And the fourth degree polynomial is probably just multiple polynomial. Yo. And the thing then has to do this. So this became extreme W. The rest should work. And then in here, I think I can treat this as a wild jump. A jump that might go anywhere. It's not that different, is it? From a jump to the extreme of a 30-degree polynomial. You can make I can just make an extreme jump. Then here I have an extreme jump plus step, so why is that different? It should be treated as a step. And then jumping to this extreme should be treated as jumping to an extreme. So now I'm still going to use the same function then, although I didn't do the other jump yet apparently. This requires no action. I just want to force it. So here's an extreme jump. Except that this one assigns the use cubic to a cubic, and I don't have a cubic now, I only have a 4th-degree polynomial. And this one assigns it directly. Okay, this is my cubic jump, I guess. This is the jump to the extreme. Okay, let's just add it in. Which means that this no longer needs to be public, so we might as well remove the badge. Handle extreme jump. Let's now extreme jump on the weight ref. Nou ja. Width. Double the extreme value. I think that's why I did make this a friend and then assign directly. I just didn't want to make give access to everyone and their friends and their enemies too, aka everyone. To this function, but yeah, maybe I should give up on trying to make it secure. So I made it pseudo-secure by giving each of these functions a pretty specific number of arguments so that you're not really tempted to abuse them. Like you have to pass a node and a step, or I don't know. These two are exactly the same, by the way, but in arguments. And here I just, pass whatever you want and I'll set it. But yeah. Now it is the case that this function is called from two different functions. That's why I wanted to be a function after all. But I want a function only to be called from these things here. So maybe I should still make them a friend if I really want that. Yeah. So a second ago I said now it doesn't have to be a friend anymore, but I changed my mind. And also this one, all of them basically should be private. I only want them to be called from these algorithm handle some things. These are very specific. I'm going to make even this one, I think, public. So by adding the badge, it can only be called from algorithm. So then it must be public in order to make it a friend, but then I add the badge and then turns it into a private function again. Very sneaky. This shouldn't even compile. Oh, this is also an extreme jump then. This one still sets it directly, and the rest now calls member functions, which is nice. What is one more here? Yeah, okay. So those two that changed the WREF directly, but these really don't need any actions ever. So it never requires. Yeah, and the other two, those two need to be friends as well again. Even though they don't change ref directly, because I'm going to make those other functions private. Now I forgot which one. Just make them all private. So that's strange. This one should be a friend now. Wait, ref badge. Friend, wait, ref badge. Oh, I've got to add algorithm. Out of line, does not match any declaration. Didn't add this one yet. Nope. Yeah, it must be added as a friend as well. And I can't type. Friend. Or we call find extreme jump directly. Yeah, we do. That one must be Pollock. And then no jump step also. So that's a little badge that gives this thing access. We'll guess this one. Uh-oh. Tja, might as well pass the value. Yeah, it compiled. That was it. So surprising. There's only one left here. Jumping back to the best minimum and then going in the opposite direction. That's quite involved. Let me first test if this works the way it is. Yep, it still behaves exactly the same. So I think I didn't screw up anything. That is the last one. So let's remove that these operators no longer access. Must call these functions to change it. Okay, yeah, here we jump back to the best minimum and then make a step basically, because the minimum was already done. Just go in the opposite direction. But it kind of depends how this opposite direction was set to know which function we want to call. Maybe I should not set an opposite direction-ish, or yeah, well, What to do that after that? Oh yeah, Lumerans. In the case of GDB, I can probably use it. Yeah. Very sometimes I do that, and then it turns out that I didn't run what I wanted. If you get what I mean, the last time. So if you do GDB foo, GDB bar, GDB bar, GDB foo, and it's kind of a gamble, but yeah, in this case, I'm almost always using the same command, running the same GDB command. I'll try to think about it next time for the GDB at least. This jumping back is a problematic for me because I'll just make a new function, really. So we're going to have something that is minimum jump. But it is more than that. You go back to the best minimum and then do an algorithm, which I forgot. I don't know anymore which algorithm. So either we're doing a step here or we're doing an extreme jump. Maybe we should just remember it. I'm not really interested in the best minimum here. I'm just interested in what happens afterwards. That could be an extreme jump, or maybe it could be one of many. Yeah, we'll have to investigate what it all can be. We're going to opposite direction. This is the only place where that is called. And the value that we get here comes from set opposite direction, which only happens here. And there we set that value, which comes from this scope and is initialized here and defined here. It's not even that much. So the kinds and types that we have is, well, this is 2 times extreme W minus W, which was just calculated here. And this is the last extreme plus a step equal to the scale. So the last extreme being this. So if you subtract that, then you get the last extreme minus the step. That's what this one is doing. This is clearly an extreme jump. This is look like an extreme jump plus step. No, wait a minute. Let me just use what I think they are being used for both W and opposite direction W. So here we jump to quotient roots for W, and that calls this. So what I really want to do is call this function at the moment I handle the opposite direction W. So by the time we handle it, we should be calling, I can just look there. Then of course the value that is being used here. And that. Yup. And this is the same as that one, but then it step in the other way. So this should be equal to that as well, except with H direction pointing the other way. Yeah, this is basically a step, although relative to extreme W. Not sure if W is this. No, it's not right. I mean, this should be. I think also last extreme plus step then. Yeah. And then what is this? Last extreme plus step. Well, that's it, right? No. And the last extreme plus step. Yeah, exactly that. Okay. So those are the functions that I want to be called at the moment that we are using the opposite direction. I think that by then I know what last extreme cubic is. That is set to best minimum. So this code already exists. The scale should be reset. Scale is reset to this. H direction is set. The only thing I need to remember is the value of the extreme itself. No, also not. That is also just the value of the last extreme. The only thing I need to do is just call this. Does the current value of W have any meaning then? At that moment. W call extreme jump plus step. Nope, it's just assigned. So it doesn't even matter what the value is. So I have to remember nothing except that I want to call that function. Aha. And then the other possibilities. Yeah, I have to remember both values, I suppose. Otherwise you have to calculate them again. Don't want that. So these two must be stored, and then I can pass them like that. And I also have to remember that I want to call this function. Same here, of course. And here again, I don't really need to store these things at all. The only downside for this case would be that we recalculate a step. But yeah, I think that step is calculated as this is just a copy of a reference. So just a call to scale step, which is also nothing. Scale step. This is the multiplication plus or minus 1 times an already calculated value. So yeah, good enough. So besides these two variables, I need to have one more variable then, which tells me which function to call. So the opposite direction is step. It's true. Now let's add that as a boolean. George. Well, I'm writing an algorithm that doesn't exist yet, so they don't. And I choose it for C++ because I don't know Python, and I've been doing C++ for 30 years. So I'm not going to change to a different language. I really hate it that my monitor is not wide enough when I'm streaming. And don't tell me I should use shorter variable names. Oh shit. This is a different class. No. So now I should automatically run into a search because I'm calling opposite direction. What is this? Oh yeah, I have to change that, of course. Well, in that case, I probably won't call them because this is where we call it. So it is if that long thing. The long thing is it's not here. Oh, it's in sample node. But this is not sample node. That must be then best cubic accessor. Now I need my comment. The commentary just set this to true. Otherwise the other one. Now these functions use the fact that last extreme cubic was set correctly. And maybe other stuff. So let's check if the other stuff is all set correctly. Start with this one. This one uses the last extreme cubic. We just said that. Again, last extreme cubic and H direction. That was also already set. H direction is fixed here. And then these two are set here. So yeah, that sets it. This is not related, that is just actually assigned it. And the other one is using nothing. Just setting these two values. It should be that easy. And these two then have set this value, so now I can do that. Yeah, no. What's the best command here? that was a jump back, so, and that's where we should go. And then we get another jump back, I think, to the best. Well, now we get a jump back to the best minimum. No, already, sorry. So here we want to jump back to this minimum. And then ended up there. Which is good, I suppose. Although I'm not sure that how it works, to be honest. To really, from here we're looking for a maximum, and then bang, we were here looking for a minimum. So I don't know, I have to look into that, but okay, it just worked the way it always did. Always has been done, has been working for the past few days. So now next we're going to jump here, back here at some point, and then look for a maximum again in that direction. I don't know, let's see what happens. Yeah, I believe there was indeed we indeed called here. This might be the same. I think it looks different though. We now have the update of the arrow update. The range update is now visible. Which is automatic result of the fact that I just condensed everything in a single function. So either we would never see that or we see it always. So that's a good thing. And this is again an assert as a result of that, I never abort. So it complains about finding the same extreme again. We already were here, so it's kind of silly to go there again and then try to find this extreme again. The same thing might have happened here, although that's the whole point. If you come here, then we have to explore the left side of the best minimum, which is here. We're exploring the left side means exploring that until we find a minimum. So we should not be aborting when we find a maximum here that already exists. We should just pass this maximum and then go find the minimum, which doesn't exist in this case, but I build in an abort when we go to minus infinity. So although it doesn't find a minimum here, we just go way down until we get not a number because it can't calculate the formula anymore, and then it aborts as well. Then we jump back here. But of course it should be really abort, because then we're completely done. Does not really abort, it continues trying to find this maximum, and then we assert, which is a good thing. So it's behaving very nicely. The only thing that I wonder about, if it's by coincidence going right, is how we pass this maximum. I guess I'll just have to step through the codes. Once we encounter number 20 here, realize that it is a local minimum which is worse than this minimum, and then see what happens. But I think I'm going to eat first. my chicken has been defrosted now. The little tiny little piece of chicken meat that I like really one bite and it's gone. So I'll be back later. Going to eat. I didn't know that I'm not going to eat immediately. I have this point and I have to commit it. Bug fix says, yeah, change the W reference to a weight reference. Back to weight instead of a double. And then we call functions on W on the weight ref instead of changing W directly. Oh, that's not even true. That is not true if you do this. Do. Hi, Alice Insights. Thank you. I should be making dinner though. But I realized here that is not true. The expected W is not updated if this function is called. That. Oh, what? It is. Last extreme plus step. I thought a step wouldn't do that. Yeah, okay. No problem then. All fine. Commit everything. Oh, it works. Especially for Alice Insights, who was already watching an hour and two, of course, but we are here. We go up because there isn't a minimum on the other side. No, we force it to go up, sorry. It's a test suit. India said, take this maximum, bitch. And then it says, it is again no nothing here, but then the test suit just bang, I wanted you to do this. So now it would jump here, which it actually does. Now we have a parabola here. This piece looks like a parabola. And the minimum of the parabola is all the way over here. And I should reject that, but at the moment it doesn't. Well, reject, I mean, the blue area gives you how much we misguessed the height, the vertical height. It should look like, oh my god, that was off. So, but then we could still jump to this minimum. Why not? Because it's adjacent to that point. Yeah, and this is still correct. It's like way off, but as long as I use the cubic between 4 and the next one, and we're still closing in on. So I don't know, maybe coincidence, but I still have to fix that. It really makes sure to do that. So in the end, we arrived a little bit down on the parabola, but now we don't jump. It's still the same parabola. We don't jump back here because we are not going to jump past the last measure point, so not jump past 6, which means that the only minimum that we have of this parabola is outside the range given by the 2 red arrows. Therefore, okay, I'm talking nonsense. It's now taking the cubic between 6 and 7 and not the cubic between 4 and 7. The cubic between 4 and 7 would make us jump to 5, but that's outside the range. Okay. Therefore, we jump to the cubic between 6 and 7, which is a minimum here. And again, and again, and again. And I'm going to speed this up, but this is how it works at the moment. And this time, the cubic between 10 and 11 does have a minimum here. We are no longer in the we're no longer in the piece that looks like a parabola, all the way down here. So now we can jump to the minimum of this cubic through 10 and 11 instead of 11 and 6. And then, yeah, 11 and 12 are on top of each other, so the next one is like bang in the middle. Sorry, it's like in a minimum. We found the minimum, yay. And then it fits a 4th degree polynomial, but unfortunately no, that thing does not have any extremes. It just goes up to infinity. Therefore, we take very carefully a little step. You see the green arrow here? Small probing step. And now we have a cubic. Between 11 and 6, that gives us a minimum. So the 4th degree polynomial was just a waste. That didn't give us anything. Now we're looking for a maximum, and yeah, that there is a maximum between 6 and 11. So let's jump here. And then the maximum is it's the same thing as before. We just have to use the cubic between 11 and 15 because it has a maximum. It's not allowed to say go for a maximum between 6 and 15. There isn't even one, but you get the point. So the same thing happens as here. In slow steps we find this maximum. Oh, we already found it. This time the 4th degree polynomial that we fit does have a minimum on the right side. But the fit, the cubic fit, must be between 5 and 6, because there is no minimum between 15 and 6. And 6 is a little bit to the right of this thing. So therefore, it rejects the minimum of the 4th degree polynomial. It says, yeah, it can't be it, because I just know that all the way up till 6 there is no minimum. So I might as well take the minimum of the cubic between 6 and the next point that we already had, which is all the way over here. That one would have been better. So, oopsies, but okay, again, between 6 and 18, we jump back there, and now between 6 and 19 is really accurate, because now we're really close to this minimum. We found 20 as a minimum. That's why it's green. However, this one is higher than that one. So we stop going in the direction to the right. Otherwise, you would have found that one and that one, that one at infinity. No, we already stop. So we jump back to 14, and then we see all those cubics, and they just go up, 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 up. So we know that only once we reach the cubic 2, 2, 3, we see that there is a maximum here. And then we want to jump to that maximum, but doing so, we end up so close to 2 that it says, might as well use 2. So it uses 2, then reuses 2 as the maximum, and then it wants to use a minimum. Well, there is no minimum between 1 and 2, because, well, it's just going monotonously up. There is no minimum between 0 and 1, because, well, monotonically up. So it must be to the left of 0, that minimum. That's why the red arrow is here. And then it is too far to the left to see. But now we go to minus infinity, like really, really, really far down. Let me see where it is now. Yeah. 28. It's now at the minus 5,000. So this is minus 90. And it already is at minus 5,000. Really tries hard to find something. Trying to see whether none here. We are now at minus 11,000, and then it can't even calculate the formula anymore. So that's where we abort, and we jump back to minus 55, because that was the best minimum. which is too close to an existing sample, namely number 14. So we reuse 14, which is here. And then we switch to, I'm not happy with this. Why would it pass not a number to the kinetic energy at this point? That's wrong. But okay. So again, a reuse of 14, and then we switch to a maximum. So now it wants to go to that side, finding a maximum again. And then it discovers that we already found that maximum before. So there must be something wrong. Which is correct, because we should have aborted. We should have seen that this point was already explored to the right, and then just stop and return this as the best minimum. That was a very, very seldom done explanation of what I'm doing and how it works. With one viewer, yay! I'm gonna